Hi students, in this video we will learn how to calculate super elevation for any road in Civil 3D. I will start with basics and you will see that if we have any IFC and there is some requirements related to super elevation, then how can we do that also. If you have any alignment in Civil 3D, then you will proceed with that. Otherwise I will just get one alignment, just leave them as default and press OK. Here we have tangent, no curves, and we need curves to calculate our super elevation. Just select tangent with curves. I'm not getting in detail with all of these tools. These are alignment creation tools, but maybe you know already them. That's why you are here to know about super elevation. Tangent, no curves, and select like this here. Okay, so it's our alignment. If you zoom here, it's a very large alignment and we have two curves, 1, 2. Here if you zoom something like this, and you will see the station and everything. Now we will calculate our super elevation on this alignment. How we can do that? Select your alignment, and from the contextual tab here we have modify panel and super elevation. Just look at here, calculate edit super elevation. Now we will click on calculate and we get two options, calculate super elevation and open the super elevation curve manager. For now we will calculate super elevation. Now we need to define the road type. Undivided, if we have road like this. If we have undivided planar, then we need to select this one. If you will select, here we have center baseline because we are going along the center line. If we have undivided planar, then we will select and you will get something like this. Pivot method should be center baseline in our case because we are using our center line. So high side location, left or right, you can take. If you can select anyone, but we will go with undivided ground. And then press next. Here we have type, then pivot method, and then number of lanes, right, how much width of the lane. If you have 3 meter for the lane width, then you can put. If you have 4 meter, then you can also put. And what will the slope of your lane? If it is -2%, then you can see here the preview -2%. If you can increase and decrease according to your design, you can also do that. And just press next. And here also outside edge shoulder, if you have shoulder of 2 meter, 1.5 meter, you can also do that, and it will also give you to change the value of percentage, slope percentage for the shoulder also. If you want to match lane slope, or you want to keep default slope, then you can also do that for the shoulder, low side and high side. Then press next. Here we have design criteria that when we design our road, we must need to follow the 2011, 2018. These are USA designs which we must need to follow. So we can select anyone here and move to the next. These are ASTO design super elevation red table. Here we have also with 4%, 6% and 8%. You can keep according to your design. It's not your job your designer will tell you that how much is our super elevation red table. If you are designer, then you must need to know about the percentage of super elevation red. Then you need to define that if you have two lanes transition length table, if you have two lanes or four lanes, you can select here. Under the here you can see here now our AASHTO 2011 ground roadway is a 10 method is selected. Transition formula for super elevation runoff, it's you can leave them as by default. If you have any criteria according to your design, you can keep, or it can be also according to your government institutes or any city is ordinance, according to state ordinance. If you are working in USA, then keep them as it is and just press finish. It will calculate your super elevation. If you see here, zoom on your alignment, you will see here the transition in, then you have full super elevation in this area, and then here we have transition out for this. If you see we have curve, two curves, then under the each curve we have transition in and out here. So we have, if you will select transition in, it will select this area like this each, and turn off, it will select transition out, it will tell you about this. So here we have start station, end station of transitions out, then transition in, and end of super elevation. We have also length, then we have overlap. Here we have very important that we have left outside shoulder and left outside lane. So if you want to change, for example, in your IFC you have any data related to super elevation that your left side is 2.5 on this station, then you can just go here and you can change them 2.5% for the outside lane, then also for the right side outside lane. So you can change them according to your criteria design. This was we calculated according to our AASHTO design, but if you are working in any another project and you want to just change them according to your design, or you just want to follow your IFC, then you can make changes in the slopes here, and once you have cross section with your alignments, then you can see main changes in your cross section, that how they change with these slope changes. So this is how you can match your IFC drawings to your shop drawing cross sections slopes. It's called super elevation tabular editor. If we need to show any percentage on any specific station, then we can also put here. If you hover your cursor on plus sign, you can also add a new super elevation critical station to add your new values on that elevation. For example, if I want to stop my transition length here, and we already stop here, but if we want to stop them here and we want to put any specifically percentage of the slope on this station, then I can add new station like this, and you can write also like this, and you can put values on this station. So it will recalculate them according to your given criteria. For example, if you see here we have alignment, you can also see your another curve. Here we have also transition in and out. For example, if we go to the alignment properties and here under the design speed, if you change them 120, then you will press OK, and you will see here we have a warning symbol because it's out of date. Our super elevation is out of date. Now we must need to calculate them. Just here, and you will see recalculate. Just recalculate because we apply new speed to our alignment, so it should be recalculate, and now you can see we have not any warning here. So here one more thing we have, sometimes clients ask to draw a super elevation view. So how can we do that? Create super elevation. Just click here and just put them as it is. Here you can just put the range of super elevation. For example, we just draw for the curve 1, like if we have from here 13 100 and here 13 to 15. Okay, so just select your alignment and here we have create super elevation view. Then just leave them as it is, and here just put user specified range. Okay, so I just want to take super elevation view on these station, between these stations, and press OK, and it will ask you to just put like this. So this is how you can create super elevation views. It will tell you if you can read them. Then you can see here we have 4%, minus 4% for another lane, and here we have also warnings which you can eliminate them by adjusting your design. And you can also use these grips here according to as we have in profiles and alignments. Also we have in super elevation views to play with these super elevation diagrams. So this is how you can calculate your super elevation on any road in Civil 3D.